Hi, hello, namaskar. I welcome everyone to lecture number 1 of Haloalkanes and Haloarenes series. Okay, so এই ভিডিওরে আমি introduction নবা Haloalkanes and Haloarenes ro. Okay, so let's start. So coming on to Haloalkanes. Okay, so what do you mean by halo? Halo মানে হচ্ছে গোটে halogen group जोटा कि represented हुए by X. Okay, so X refers to fluorine, chlorine, bromine and iodine. Clear? What is alkanes? Alkanes refers to saturated open chain organic compounds which contain carbon-carbon single bonds only. Okay. So how are haloalkanes formed? If we replace a hydrogen atom in alkanes with a halogen group X, it gives us haloalkanes. Okay. So haloalkanes are the derivatives of alkanes. Let us take two examples. So before we start, what is the general formula of alkane family? That is CnH2n plus 2. Okay, so if you put n equal to 1, so what will be the formula? That is C1H4, which is equal to CH4, that is methane. So methane is the first member of alkane family. So let's do the structure of methane. So methane contains 4 hydrogen atoms. Okay, so what we will do, we will replace this hydrogen atom with a X group, that is halogen group. So what we will get? Here we will get X and here will be hydrogen. Okay, that is CH3X. So this is our haloalkanes, or you can say them as what? Alkyl halide. Alkyl halides, and they are represented by RX. Okay, R refers to alkyl group. Clear? Very easy. So haloalkanes or alkyl halides are the derivatives of alkanes and they are formed like this. Okay, let's take the another example. For example, if you put n equal to 2, it will be ethane. Okay, so what is this formula of ethane? That is CH3 or okay. So here also what we will do, if you do the structure of ethane, so these are the hydrogen atoms. Clear? So here also, if you replace this hydrogen with a X group, it will give us alkyl halide. So check here. Here it will be CH3, here it will be CH2, and here it will be X. Okay, so this is represented as C2H5X, or what is this? Ethyl halide. Okay, done. So this was our haloalkanes. Okay, now coming on to haloarenes. Here also halo refers to halogen group, and arenes refers to aromatic ring or aromatic hydrocarbons, which we have studied in class 11, that is benzene. Okay, so the first parent organic compound is benzene, through which many other derivatives can also be formed. So what is the formula of this aromatic ring known as benzene? So the formula of benzene is C6H6. Okay, done. So here also we will do the same. What we will do? For example, we will replace this hydrogen atom with a halogen group. Okay, so what will be the structure become? Here there will be 5 hydrogen atoms. Here it will be X group, which will be substituted here. Okay, so how can we represent that? C6H5X. Okay, or PHX or ARX. Okay, so these are the general representation of haloarenes. PHX or ARX. AR refers to aromatic ring. This PH refers to phenyl ring. Okay, it's the same. Okay, PHX, done. Okay, so haloalkanes and haloarenes are the derivatives of hydrocarbons. Okay, clear? So we shall discuss about them in this chapter, and these are the topics which we are going to study ahead in the coming classes. So in this video we have covered the introduction. So in the next video we study about classification, nomenclature, methods of preparation, physical properties and chemical properties. Okay, now we will discuss about the classification of haloalkanes and haloarenes. Okay, so number 1, on the basis of number of halogen atoms which are attached. Okay, so the first category is on the basis of number of halogen atoms which are attached. So coming on to haloalkanes, for example, see here CH3Cl, another example. So this is mono haloalkane because one halogen group is there. Okay, so mono haloalkane. This is, there are two halogen group attached, so it will be called dihaloalkane. Done. Here it is 3, so what will it call? Trihaloalkane. Clear? Okay. But see here, this dihaloalkane can be categorized into special two names, which is known as geminal dihalides. Geminal dihalides. Another is vicinal dihalides. Okay. Vicinal dihalides. So what is geminal dihalide? In geminal dihalide, the halogen group will be attached to a single carbon. Okay. So see here both the halogen group will be there. Okay. It is called geminal dihalide. In the single carbon, two halogen group will be attached. But vicinal is this. That means in adjacent carbon atoms, means nearby carbon atoms, both the halogen group will be attached. So this is your vicinal dihalides. Okay. So this was about our haloalkanes. Now coming on to haloarenes. So similarly, if we consider an aromatic ring, okay, if here one attached, so it will be known as mono haloarene. Okay. If there will be two, for example here, so it will be called dihaloarene. Okay. And so on. Okay, so this is our first basis of classification, that is on the basis of number of halogen groups attached. Basis of classification is on the basis of hybridization of the carbon atom to which the halogen group is attached. Okay, so hybridization of the carbon atom to which the halogen group is attached. Okay, let us take example. So first let us consider about sp3 hybridized carbon which is attached to halogen group. Okay, so number one, that is alkyl halide, so which I have already studied in the introduction class, or haloalkanes. Simple. For example, CH3Cl or CH3CH2Br. Okay, so see here, so this is halogen group. Halogen group is attached to that carbon which is sp3 hybridized. How? Because it forms 4 sigma bonds. If you open up this structure, it will look like this. So look at this carbon atom. So this halogen group is attached to this carbon atom, and this carbon atoms forms 4 sigma bonds. 1, 2, 3, 4. Hence it is sp3 hybridized. Clear? So this is the same. Okay. The second is, this is very important. This is known as allylic halide. Okay. What is it is called? Allylic halide. Okay. So what do you mean by allylic halide? Means, for example, look at this structure. So see here, this X or halogen group is attached to sp3 hybridized carbon. Okay, this is a sp3 hybridized carbon, but this sp3 hybridized carbon will be attached to a doubly bonded group, that is alkene. Okay, that is known as allylic halide. So this carbon is referred to as allylic carbon. Very clear? Okay. So in allylic halide, the halogen atom will be attached to that sp3 hybridized carbon, which will be attached to a alkene or a double bonded system. Done. Next, coming on to number 3, that is benzylic halide. So this was the case of aliphatic compounds. If we consider an aromatic ring, it will be called as benzylic halide. So it is the same. How? See, for example, if we consider an aromatic ring, so this is the doubly bonded system. Okay, so next to the doubly bonded system, there will be sp3 hybridized carbon, and to that carbon a halogen group will be attached. Simple. It is known as benzylic halide. So this carbon is sp3 hybridized, and it is known as allylic carbon. Done. Clear? So on the basis of hybridization of the carbon atom to which the halogen group is attached, first if you consider about sp3 hybridized carbon, we have 3 categories. First is our alkyl halide, second is our allylic halide, and third is our benzylic halide. So now coming on to sp2 hybridized carbon. Okay, sp2 hybridized carbon which is attached to the halogen group. Okay, so first categories are vinylic halides. Okay, vinylic halides. Okay, so what is vinylic halides? See here, CH2 double bond CHX. Here the halogen group is attached to a carbon which is sp2 hybridized. Simple. Directly attached to a sp2 hybridized carbon, that is known as vinylic halides. Number 2 is aryl halides, which you have already studied in the introduction class. So what is aryl halide? Simple. Aryl group or phenyl group which is attached to a halogen group. Simple. And if you open up the structure, double bond, double bond, double bond. So see here, directly attached to double bonded carbon is this halogen group which is sp2 hybridized. So this is our aryl halides. Done. So this is our classification of haloalkanes and haloarenes. Okay. So in the next video we shall start with the nomenclature, that is IUPAC naming of this haloalkanes and haloarenes.